So representing a, whoops, I need to grab, there we go, my pointer. Representing a, as user reading guidance, by the way, for 4.2, representing a geometric relationship. So again, we said this is going to start out as relationships. So looking for patterns. In the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. So one rectangle, right, has a perimeter. We can kind of calculate that, and I'm going to zoom in here just a second so we can calculate that. And that's, notice I kind of stole that before in one of your examples in the vocab from this. But we can create, so the number of rectangles, one rectangle, and remember the formula for perimeter is 2 widths plus 2 lengths. So notice here that this is always going to stay 6 on this side, right? But it's the width that's going to change. The length's always going to be 6, but the width's going to change. 1 rectangle, 2 rectangles, 3 rectangles, 4 rectangles. Always going to stay 6. So that 6 is not, it's a constant. It's not an input or an output, right? Or not independent or dependent variable. So anyway, number of rectangles, 1 rectangle, a width of 1, 2 rectangles, a width of 2. And notice how that affects the perimeter here. So with 1 rectangle, we have 2 times 1 because you know 1 and 1 here, and 2 times 6 because you go 6 and 6 because we're talking perimeter. When I have 2 rectangles, notice that my width stays the same, right? Or my height, I'm sorry, 6 and 6 there, right? 2 of those. But the width is now doubled. 3 of them, it triples. So there's a distinct pattern here that we're looking for. And the way to solve here, we start out by making a table. It's a good place to start. Use x again as the independent variable. That's the inputs. And y is the dependent variable. That's our outputs. There we go. Also stated right here. X is the number of rectangles. Y is the perimeter of the figure. Write each pair, input and output. So we did that here. Look for a pattern in the table. So describe the pattern in words so you can write an equation to represent the relationship. So obviously multiply the number of rectangles in each figure by 2 to get the total length. That's the top and the bottom sides. Then add 12, right, because that's our height on the left and the right side. So in other words, put that into a formula here. 12 added to 2 times the width. That's our x. Use the table and make a graph. So we have a table. Then we can graph these. And if you remember, and we're going to maybe review that. Let me zoom in real quick to do that for you. Our points here. There we go. Let's make sure I can see them all at the same time. All right. So when we go to graph, this is the point 1, 4. So 1, 1, 2, 3, 4. 14, I'm sorry. 1, 14. Oh my gosh, if I could actually read, that'd be crazy. So 1, and this is obviously going by 4s, right? 4, 8, 10. Is that right? 14. There's 14 for us. 4. I just said 4, 8, 10. 4, 8, 12. There we go. There's our 14. For Pete's sake. 2, 16. So 1, 2. So we start at the origin, right? 1, 2. And then it goes up. 4, 8, 12, 16. So I got it right that time. 3, 18. So start at the origin again. The 0, 0. 1, 2, 3. And then we go up, right? 4, 8, 12, 16, 18 is our 18. So we get the idea of graphing. Hopefully you remember that. If you're not sure, come up and sit with me and we'll go through graphing just to make sure you've got it. Remember, x is going positive. So if I draw that, draw the plane. We'll make a quick side note here. If I were to draw the plane here, right? Remember that x goes positive this way, x goes negative this way, y goes positive going up, and y goes negative going down. Just a quick review. Kind of hope you remember that. So anyway, back to the matter at hand. Let's zoom out here now that we know how to graph it. So that's that. I guess that was what was expected. Make a table. Use the table to make an equation. Use the equation then and the table to make a graph. So this time, in this diagram below, what is the relationship between the number of triangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. Notice, by the way, perimeter is just around the outside. This internal side is never part of a perimeter. Just like here and here, never part of the perimeter. This, not part of the perimeter. Just the outside of the figure each time is the perimeter. And this one's kind of a fun one. So the relationship between the number of triangles, so 1, 1, 2, right? 1, 2, 3, 1, 2, 3, 4, and the perimeter of the figure. And again, we want to make a table for that, right? So if we were to grab this table, so one triangle has a perimeter of 10. 3 plus 3 plus 4, 10. Two triangles has a perimeter of 3 plus 3 plus 3 plus 4, 14. Three triangles, 3 plus 3 plus 4 plus 4 plus 4, 18. Four triangles, so on and so forth, right? And again, remember those internal sides are never part of the perimeter. So if you look at the numbers, now we can see what actually is happening, right? So that's why we make the table. So you can decide, oh, here's what's really going on. So multiply the number of triangles by 4 and add 6. That's really going on. So 1 times 4 is 4, plus 6 is 10. 2 times, right, plus 6. 2 times, right, or 4 times rather, plus 6. 4 times plus 6. So recognizing that pattern's really important. Again, now how did I know what the pattern was? Sometimes, for right now, we'll just say you got to sit and kind of look at it until you figure out what the pattern is and what's going on. And for the most part, it's going to be something pretty straightforward like this stuff. It's not going to be something crazy. So then, second part of that, you're going to go back and graph those points, or third part, or whatever part we're really on. So the point 110 over 1, up 10. Over 2, up 14. Over 3, up 18, right? And the 422 doesn't fit on the graph that I have here, so there you go. There's got it 1. Alrighty, continuing, more representing a linear function. That's really what we're looking at here. Looking at it as a relationship, looking for the pattern. We're not concerned about, obviously we're doing some graphing here, but my concern right now is that you see them as a relationship and see them as patterns. Alrighty, so let's read this one together, shall we? Or I'll read it and you just follow along and listen. The table shows the relationship between the number of photos, x, so it's x, right, the input, you take, and the amount of memory, y, in megabits left on your camera's memory chip. So you get the idea here, right? Every picture you take, you have less megabytes left. Is the relationship a linear function? Describe the relationship using words, an equation, and a graph. So 0 photos, you have 512 megs on that thing. Take 1 photo, you're down to 509. 2 photos, down to 506. 3 photos, down to 503. So you can see you are using like 3 megabytes each picture. It's kind of a pattern going on here, right? Well, you can obviously probably discern that's going to be a linear relationship. So what do you know? The amount of memory left given the number of pictures. Other representations that describe the relationships, that's what you need, right? So I need to write a function, right? Looking for a pattern, that's your plan here. The amount of memory left is uniquely determined by the number of photos, that's x, that's your input, you can take. You can see the table above, where each input value of x corresponds to exactly 1 output value of y. So y is a function of x. Surprise, surprise, right? So input, output. To describe the relationship, look at how y changes for each change in x in the table below. So 0 photos, right? 512. We kind of said that already. 1 photo. So notice each time, right, you're taking 1 more photo. Over here you are subtracting away 3 megabytes. So we need to write a function to go with that. So y equals 512 minus 3 times the number of photos. By the way, this is a good time to bring up reasonableness of answers, right? And inputs. Can you have negative photos? No. You can't go, well, I took negative 4 photos, so I added memory onto here. That doesn't make any sense. So no, that's not the case. Going to graph that thing. So obviously going to make points. Our points are 0, 512, 1, 509, right? 0, 512, 1, 509. And it just keeps decreasing at a nice line as we go down. So there you go. Alrighty, so your second got it. Is the relationship in the table below a linear function? Describe the relationship using words, an equation, and a graph. So this one doesn't really give us much information. It just gives us a graph. So 0, 8, 110, 212, 314. So you got to kind of describe it. What's going on here? Well, whatever 0 is, I start out with 8, right? I add 1, I get 10 of them. I add 2, I get 12. 3, I get 14. So you start trying to take a look as what's going on here. Well, Here, right, plus 1, right, plus 1, plus 1. Down here, I get plus 2, plus 2, plus 2. So start thinking about it in that maybe in that format when you're getting ready. Okay, well, what's my function going to be? Well, in words, let's bring that up here. There we go. In words, the value of y is 8 more than twice the value of x, right? So the value of y is 8 more than twice the value of x. Double and add 8, double and add 8, right? Kind of looking at what's going on here. So double this, add 8. So we can put that into, again, how did I come up with that? Kind of looking at the pattern until you kind of figure it out. So double your x, right? Add 8. Double your x, add 8. So on and so forth. And yeah, that makes a nice linear graph. There we go. So you can graph those points. 0, 8, right? 1, 10. 2, 12. Over 2 up 12. So on and so forth. Let's take a look at part B of that real quick. Does the set of ordered pairs 0, 2, 1, 4, 3, 5, 1, 8 represent a linear function? And explain. Well, no. The input value of 1 has more than one output value. Tried to trick you, didn't I? Right? So my 1 here is tied to a 4 and an 8. I immediately, and you couldn't graph it, you can take a look at it, but immediately see not a function because this x is tied to more than one y. Not a function by definition. And I'm going to try to trick you with that. I will, so pay attention to that.